A challenge that's specific to mass timber buildings is, well, people do want to have exposed timber, and that does add another element of we have a surface that's exposed to the fire. What we want to do is to make sure that we design for a safe building and that we can communicate that in a way that we can rely on it, right? Performance-based design is the process for that.
This time, learn about fire risk in mass timber, how it's defined and how it's affected by variables such as height and occupancy type, and find out how performance-based fire design can help win approvals. Join Senior Principal Paul Becker and Vice President Kristina Rogers, both structural engineers based in Portland, Maine, as they talk with Ali Ashrafi about mass timber and fire safety.
Hello, everybody, and welcome to another of our Mass Timber podcast episodes. I'm Paul Becker, joined by my colleague, Kristina Rogers.
Hi, welcome back.
Good to see you again, Kristina. Today, we're going to be joined by Ali Ashrafi, who is an expert in our forensics and design studio in the DC office, Thornton Tomasetti. He's a specialist in performance-based fire engineering, and he brings a real unique perspective that involves investigating real-world fire events and then shaping fire strategies for the new buildings that are designed. And we're going to talk to Ali about the work that he does day to day, how his forensic insights inform his designs, and hopefully we get into what mass timber teams need to understand about building codes and restrictions and opportunities for innovation working around the code. So, hello, Ali, and welcome to the podcast.
Thank you for having me.
So, Ali, Paul and I both work in the structures practice primarily, but your work spans between forensics and design, and you have this specialty in fire performance. Can you talk to us a little bit about what a typical day looks like for you in the office when you're focused on fire and structure combined?
Sure. I do like that I touch both sides of it. On the forensic side, which includes fire, but also just looking at structures in general, we really see how things behave in real life. So I see how materials break. I see their strength. I look at fire scenes and I see how the fire dynamics varies from one side to another side. So having seen how things don't work or how things do work in extreme scenarios gives us really good sense of what to expect from different materials and systems. And so when I go to the design side, I bring that to help us design buildings that are better, safer, and designs that are more to the point. So we do things that actually improve the safety of buildings. So that's what I like about that.
So Ali, working in both design and then forensic work, what's the most appealing thing to you about applying your performance-based fire engineering experience to projects, including the mass timber projects that we do?
Maybe what I like the most is that we don't do cookie cutter projects. We're not going to repeat the same process every time. When I'm looking at the project, everything about that is specific to it. So in terms of the fire hazard, for example, we look at what's relevant to that building. Depending on what you have inside, what kind of occupancy you have, what's the building made of, you might have different fire hazards, and then the building response is also different. The risks to the people is also different. And so what I enjoy is coming up with the best solution for that building and the people that occupy that building, which is challenging and interesting every time.
In the mass timber world, we're often looking at the new design codes, and we're pointed to height and area restrictions that are increased from previous iterations of timber design. But there's still limitations. Can you help us better understand the limits of those constraints and kind of where they come from the fire side?
Sure. That's a great question. As you mentioned, there are a few key parameters that define what the code asks you for a building, including a timber building. The most important being the height of the building, the area of the building, and the type of occupancy that you have there. So rationally, if you have a shorter building, if you have a smaller building, if you have a building that has less sensitive occupancy, the code is more lax in terms of what it asks from a building. As we start increasing those parameters, dialing them up. So you go to a taller building, or you have a more sensitive occupancy inside a building, or you have a larger area, you do want to add layers of safety to the design so that you're still maintaining something that's considered acceptable to the society's standards. So in that context, as you mentioned, we used to have mass timber for shorter buildings, and in IBC 2021 and then IBC 2024, that limit has been pushed beyond what it used to be. Now we have buildings that in theory can go up to 18 stories. That comes also with additional restrictions. So if you're doing a taller building, there are more restrictions on how much of the timber you can expose, for example, or what kind of egress you have in the building, what kind of fire suppression system you have in the building. You want to have those extra elements to make sure that you're maintaining a level of safety that's adequate for that building. Now, the challenge here is, as you start going to these taller buildings, a few things become harder. So if you have an incident, it takes longer for the fire department to get in.
That where the height restrictions come into play more so?
That is part of it, right? So when they're
Okay.
looking at it, height is a big factor in fire safety design as a whole. So not just for timber buildings, but that's important. At some point, they have to get in to help, as opposed to being able to do that job from the outside. The same story is true for evacuating people inside the building. So if you have a shorter building, much faster to get people out. Immediately, you have reduced your risk. If you have a taller building, that becomes more of a challenge, right? And then a challenge that's specific to mass timber buildings is, well, people do want to have exposed timber to some extent, right? They want to see it. And that does add another element of, you have a surface that's exposed to the fire. So the question here is, what is that right balance of providing the layers of fire safety systems so that you are pushing the limit of what we're doing compared to what used to be done in the past, but at the same time, the occupants are safe, the fire department can do their job if needed. And in reality, you've reduced the risks to the point where hopefully you are not having to deal with that in the first place.
So, Ali, the code's improving in terms of its increased areas, heights, but maybe sometimes that's not enough for us, right? We have projects where we want to push that height. How does performance-based design approach help a project move beyond the code prescribed limits?
So if you think about performance-based design, what it means, it really means that you are trying to define, I want to know what happens in case of a hazard. So in this scenario, of fire, if there's a fire, I want to know what's going to happen to the building and the occupants, and that consequence is acceptable. It's within what we consider to be reasonably safe. So that really is important when you are pushing past where the code provides the limitations. The prescriptive limits of the code presume safety. So if you're meeting those requirements, the code presumes that you're providing adequate safety. When you are pushing past that, both from our own perspective of making sure that we are providing a safe design, and also from the perspective of getting approvals for them, it is helpful to be able to go to that next step, do more of the engineering, sometimes even improve the safety with different measures beyond what was there in a prescriptive design, so that everyone has confidence that what you're getting is safe enough for the public, for the residents, and we all feel comfortable about that.
Well, maybe to kind of expand on that, what specifically about a project would cause you to think this building has some unique fire hazards that would require it to need more fire safety than the code? Does that ever happen?
It does. I would say, I'm just going to give you a broad answer because the answer project by project would vary, right?
Yeah.
But you highlighted a key point. So a different fire risk, for example. So everything else being equal, if you have a different fire risk, you might want to look at that. So a timber building, by definition, is a different fire risk compared to a building that's built of non-combustible. So part of that is already incorporated into the prescriptive code requirements. The code is more restrictive on timber buildings because of that, because there's an element of fire risk that's different from a typical building. I would look at other factors that could be relevant too. So, for example, if you have a building, what's next to it? Do you have other buildings of similar exposure next to it, or is it occupying one block but you don't have neighboring buildings? That's relevant. What kind of occupancy do you have there? Is it a population that's healthy, up and about, can move in and out easily, or do you have a more vulnerable population there? So that could be something that's relevant because it affects egress time. What kind of access could the fire department get, for example? Do you have restrictions based on where it is or not? Can they get to the building from multiple directions? And then there are things about just what the building is that have an impact. So how you shape your geometry, how much windows do you have? How much of it do you want to expose? What kind of occupancy you have, which also informs how much combustible material have inside the building. All of these are different factors that you can weigh in to see where your building is in that spectrum. And then based on those factors, sometimes you might want to say, you know what, I'm going to try to do a little more, go toward a more quantitative approach towards fire safety, which is performance-based design.
Ali, maybe I'm kind of curious, what does it look like for you when you're doing a fire performance-based design in terms of, the materials you use or the tools you use? How does that work in practical life?
That's a great question. So in reality, we try to have a balance of looking at different analytical tools. We want to be able to analyze things and know how much force we have and how much stress we have in our members. But also we want to be very cognizant of experiments and past knowledge that we've gained through research or through our work as investigators of fires. And we bring both of those things because the idea is you want to have a design that's robust. We want to have something that allows for the fact that each fire is different, each building is different, and you can't exactly predict what's going to happen. So bring the experimental data, the research in, use our analytical tools, and then use both of them really as tools to help us shape a robust design.
Let me ask you this. Have you done any forensic work where you've had to repair fire damage in a mass timber building and seen that done successfully?
No, because there haven't been a lot. Like we've seen research that's done to show that it can be done, right?
Yeah.
But the fact is we don't have a lot of mass timber buildings that are experiencing these large fires. We have not.
I've seen in our work as more municipalities are accepting different versions of the code and the versions of the code that we've been talking about, 2021, 2024, where we're in a location where those iterations of the code haven't been accepted. There's a lot of interaction with building officials about what we think in our professional experience is safe and reasonable. How does performance-based work build confidence with that group?
So if you think of it from the perspective of the authority having jurisdiction, they want to make sure that if they approve something, it's ultimately safe for the people that are going to be in that building, whether they're working there or they're living there. And what we want to do is to make sure that we design for a safe building and that we can communicate that in a way that you can rely on it, right? Performance-based design is the process for that. So unlike the standard design in fire, which is prescriptive, where you actually don't quantify what you're going to get, performance-based design is very explicit. You define, this is what success looks like. These are my assumptions regarding how the building is going to behave. You can add your layers of safety and robustness to the design, and it's a rational design. So it's straightforward to then explain that to someone. It's a transparent process. They see what your assumptions are. If there's a disagreement, if they want a different sets of assumptions, you can go through those discussions, but ultimately you can think of it as you know what you're getting. And so that puts the AHJ in a better position to say, yes, this is something that I understand. And so then I can approve this.
Makes sense.
I have a question on how you go about doing your work. You said it's based on a lot of evaluation of forensic fires and seeing how things started, and then also a lot of research and testing. So what do you see as the areas of the most current research or testing that is of interest to you, and what is that revealing right now?
So I think there's a lot of research that's going on into fire dynamics in a timber building. So if you think of it, what makes a timber building different from another building is the fact that timber itself can interact with the fire and shape what that looks like in terms of the duration, in terms of the temperature that you're exposed to. And timber is also a less standard material, right? You can have a steel built to specific specifications. For timber, you're cutting a tree and you're using that material, and each tree is somewhat different. So there's a lot of research to understand that variation in the different types of timber, and also how the elements of design can shape the fire dynamics. So same timber, but you have a room that's larger or smaller, that has a larger window or smaller window, that has less or more combustible stuff in it. How does that change the fire dynamics? That's a very active field of research. We would include that information as part of the design, but it's also evolving. And so it's important in the timber field, especially to keep up with where things are, know what the boundaries of what we know and what we don't know are, and make sure that we incorporate them to ultimately get a design that's robust, that we can count on it, and it's not too sensitive to the assumptions of the specific type of wood, or if you change one of the assumptions of design slightly, the performance will be so different.
Do you see those types of variations being somehow incorporated in upcoming codes? You know, the size of the room or the openness of the space, or do you think that's just too nuanced to be able to include in a code, and it's going to be left to the designer in a performance-based design to address?
I could see it coming at some point. I'm not sure if that's a very near future. This is still an area where you don't want to just put something there and say, okay, now you're done. You don't need to do your deeper dive into it. I think we're in an area where we still want to make sure that the professionals that are doing the design do the deep dive, they fully understand what they're doing, and don't rely on just the language and the code there.
So, drawing from this experience, what lessons should teams keep in mind as this field continues to grow and as we're pushing boundaries and kind of seeing different variations of timber design in the industry?
I would say a few key points. One thing that I've mentioned a couple of times, you're looking for robust designs. Don't design everything to the T with perfect assumptions. We have to account for the fact that fire is a complex phenomenon, and we don't have full control over every parameter. So we need to make sure that our design covers a range of events. I would say performance-based design is a great tool to allow for doing innovative work, and at the same time knowing that you have a safe design. So you have confidence that you're doing what you need to do. In all of these, I think it's really important to be proactive and have early discussions with the owners, with the design team, to establish what is your fire safety strategy. How are you trying to get there? What are the choices that you're making, so that everyone is making informed decisions and moving in the same direction. And I would say maybe the last point is just use all the information that we have. We do understand how different materials behave in fire, including timber. We have a good understanding of fire dynamics when timber is exposed, but those are also fields that are active, and we continue to learn more things. So use the analytical tools, use the experiments that are out there, keep up with the research, and use all of that information to have a design that have full confidence in.
Well, that's great recommendations, Ali, and great perspectives. And one of the things that I heard you say was be proactive and early engagement, with the owners and stakeholders, including the code officers. And I think that's a common theme that we've seen in this podcast series. As mass timber is a relatively new material, I think getting everybody involved in the conversation and understanding the goals and the holes in the road that we have to avoid is super important. So Hey, that's all the time we have today, Ali, but I really want to thank you for your time and for giving us a roadmap for how we might be able to use performance-based design. And I'm looking forward to continuing the conversation with you and seeing what new information you can share with us all.
Thank you. Great conversation.
Kristina, thanks for joining in today. And we'll look forward to talking to everybody soon. Take care now.
Tune in for our next episode, Vibration and Acoustics in Mass Timber, and like, subscribe, follow, or comment.